Okay, so let's talk about the square root principle. So this is an extension of the first lesson from this chapter. This is basically lesson 1.1b, I guess you would say, the second half of that lesson. So there's something called the square root principle. And this is when square root, I'm saying square root, we're dealing with square roots. We're talking about even roots. So when n is an even root, we can take the nth root on each side, but if we do that, if we take the square root or nth root, an even root on both sides, don't forget to put this little plus or minus right there. So that's super important. You've got to put your plus and minus if you take the square root of both sides. So let's look at what this problem, what it looks like for a problem here. So if you have x squared equals 9, you probably know that. You know that 3 squared is 9, and negative 3 times negative 3 is also 9. So when you take the square root of the whole side, you have to put plus or minus on one side. And I usually put on the side where the variable is not. So the square root of x squared is just x. Square root of plus or minus, square root of 9, so that's just plus or minus 3. So there's really two different answers there that you get. So here, before you take the square root of the whole side, or fourth root of the whole side like you might hear, we really need to get just one thing on each side. This would be kind of, you could take the whole side there, but I don't know what the fourth root of that is. There's no nice way to take the fourth root of a binomial like that and have it work out very well for you. So I might move this 16 over to the other side. So we have now, we start with x to the fourth equals 16. We start with that. Now we're in a more reasonable path here. We can take the fourth root of both sides. And when you do that, hopefully you know how to take the fourth root of both of those sides. And so you get x on the left equals, oh, you look what I forgot? Don't forget the plus or minus. When you take the even root of both sides, you've got to put a plus or minus on the right-hand side. So don't forget, the fourth root of 16 is actually 2. So the answer is plus or minus 2. So get another example, and you'll see problems like this in your homework. So here I can take the square root of the whole side. Now fortunately the whole side right now is being put to the power of 2. So if I take the square root of the whole side, and the square root of the whole side, don't forget plus or minus on one side, that should simplify nicely in the left. I just get x minus 7 equals plus or minus square root of 3. And then final step, move that 7 over. And when you do, when you add 7 to both sides, I think it's just better to put the 7 in front. It kind of flows better. It sounds like you're a mathematician when you do it that way. So it'd be 7 plus or minus root 3. And those are your answers. That's really 7 plus square root of 3 and 7 minus 3. There's two answers there, and those are the answers to the problem posed. So oftentimes you're going to get two answers when you do this. Now when I take the cube root of both sides, I get x equals, I just get plain old 2. What's the cube root of 8? 2. Could the cube root of 8 also be negative 2? Negative 2 times negative 2 times negative 2 is actually a negative 8, which is not the same thing as, that is not the same thing. Negative 8 is not the same thing as positive 8, so that one doesn't work. So negative 2 doesn't work in this case. So we only have to take, when it's an odd root, we don't have to worry about the plus or minus every time we take the odd root of both sides. So you really want to isolate first. So try to get that x squared all alone if you can before you do anything to both sides. So I'm going to move that over first. You get 2x squared equals, subtract 1, that would be 8. Divide by 2, divide by 2, you get x squared equals 4. Now you're ready to take the square root of both sides. And so when you do that, don't forget, even root of both sides, you have to remember to put plus or minus. It's easy to forget that guy. And so the final answer would be x equals plus or minus 2. You're going to have two answers in most cases. Dealing with fractional exponents. Again, this idea of isolating the term with the exponent. We want to get this x to the 2/3 all alone. I'm going to get this other things to the other side. So I get 4x to the 2/3 equals 100. Divide by 4, you get x to the 2/3 equals, what is that? Divide by 4, so that would be 25. So really to solve at this point, I've kind of isolated it. Now I need to do something to both sides. In this case, a square root or a cube root is not enough here. I've got a power and a root, so I really need to kind of do the opposite of both those things. Instead of second power, I want to do a second root. Instead of a third root, I'm going to do a third power, the 3 up there. So to put both sides to the 3/2 power. What should happen if I do that, oops, sorry about that. What should happen is this power, of reciprocal times, a fraction times its reciprocal is always 1, so I just get x on the left. Now I do this in 2 steps, right? The second root of 25 is 5, and 5 to the third is 125. So I've got my answer. So the key is isolate that exponent first, that variable with the exponent, then do something to both sides to get rid of it. These are called literal equations. It's when you take an equation and you solve for a variable in there. So there's a lot of variables. These are actually harder to solve than just regular old equation like 2x plus 1 equals 5. So if I want to solve for the r, I need to isolate it, right? So I need to move that pi over to the other side. I would probably divide by pi in this case. So I get, I'm going to put r squared on the left here. So I get r squared equals a over pi. We just learned how to deal with this. You take the square root of both sides, and don't forget, you want to put plus or minus on the side you're not solving for. I'm solving for r, so I'm going to put plus or minus on both sides. And I get r equals plus or minus the square root of a over pi, area over pi. And I've got it. It doesn't really get any simpler than that. That's just, we're done. It's going to be kind of a messy answer. We're not used to problems like that, but that's how you do that kind of problem. Let's try a few more literal equations. So solve this one for h here. So what we're going to do is we're going to go, so get this h all alone. So there's 2 ways to do that. I might do that in 2 steps. I might multiply by 3 first on both sides. So we get 3v equals s squared times h. If you're solving for h, you're going to divide by s squared, divide by s squared, and you get h equals 3v over s squared. Those cases. And you got it. So you should kind of get used to this kind of thing. Solve for h here. You could multiply everything by 2 to get rid of that fraction, so I'd have 2v equals 2s squared plus s times h. So we're going to solve this one for capital R, and actually it's not going to take too long. It takes about 2 seconds if you divide by a quantity, a plus b. That cancels, you get R equals that. So that's your answer there. Now, I did that for a reason, because we're going to try to solve this one for b, and it's a little tougher. You can see that there's b's on both sides. The first thing I might try to do is isolate the b's. So I'm going to put the b's on one side and the r's and the a's on the other side. So I'm going to have to distribute here, so I have r times a plus r times b equals a times b. I'm going to kind of get this term over there and this term over there, so I'm not going to show my work here, but I think you'll follow. I have rb minus ab equals negative r times a. Okay, so now I have the b's on the same side, and this is the kicker. If you can get this step, you are well on your way to solving this problem. So if you think of this as having a parentheses around it, do you see a GCF that's common to both terms there? So I'm going to pull that GCF out. It's going to be b times r minus a equals negative r times a. Now, I don't care how messy the answer looks at the end. I just want to solve for b. To do that, it's just one more step, kind of like this one was. To divide by r minus a, divide by r minus a. It's a minus sign there. That cancels. You get b equals negative ra over r minus a. And that's it. We don't care how messy it is over there for this type of problem, for literal equations. we want to just solve them. And the reason they're called literal equations is, like for example on this one, really because this is a radius and this is an area, these are actual real world things. Radius has to be a positive value. Same thing for an area. We don't have negative areas. At least so far in math we haven't seen that. So I really don't have to put plus or minus there. I can come back and say, well, really, in this case, even though normally I would always put plus or minus there, because these are all positive values, the radius has to be a positive value, the area has to be a positive value, I really don't need to concern myself with the plus or minus. So occasionally on the real world problems, when you're dealing with actual measurements, you don't have to worry about plus or minus when you solve for that kind of thing. That is the end of your screencast. Well, let me say one more thing. I want to hit this because every year it happens. So a lot of students, they see it. I'm going to use numbers so you see it a little easier. 3 squared plus 4 squared equals 5 squared. We know that's a true equation. A lot of students in my class, maybe not on this easy of a problem, but they'll think to themselves, oh, something plus something. I'm going to take the square root of that guy, square root of that guy, square root of that guy, and they think they're being fair. Let's see what happens. 3 plus 4 equals 5. Well, that's not true. 3 and 4 is 7. That's not 5. You cannot take the square of each individual term. It is not allowed in math class. It's not going to work out very well for you if you do that. You are allowed to do this. You can take the square root of the whole side, square root of the whole side, as long as you remember to put plus or minus. So now I have the square root of that quantity in there, right? 3 squared is, what, 9 plus 16, which is 25, equals plus or minus 5, right? Square root of 25 there. And we get square root of 25 is 5, so 5 equals, at least now, you know, we have something, it'll kind of end up weird because it equals plus or minus 5, but we have kind of a normal type problem. So when you see something like x squared plus 9 equals, 10 or something like that, do not take the square root of each individual term. You would take the square root of both sides, plus or minus, and then you go on your merry way from there. So hope that helps, and please don't make that error. You take the square root of the whole side, but not each individual term.